Hey, this is Mr. Weiss here. This is the 12th of May, and it's 7D physics. So today we're going to continue with convection, some applications, and then begin with radiation. So that's our plan today in case you couldn't be here to see the video and you're watching it at this time. I'm going to wait for some folks to check in and give them a few minutes, and I'm going to take roll as we do so. So once people are here, go ahead and say hello, and I'll know who's joining us this morning. Lisa's here. Why am I not surprised? Good morning, Lisa. And someone's joining you. Let's see who it is. Let's see, my second person. Could it be Aurora, or will it be somebody else? Or maybe Stephanie? That's the big question. Well, Lisa, since you're the only one here right now, you were able to do the density lab, am I right? I think I got yours in. Okay, good. All right. Well, my next assignment I'll plan will be easier for a lot of you students to get to, so everybody should be able to get to it. Okay. All right. Who else is with us now? We've got another person. All right. Well, let's write up some stuff here while we're waiting for folks here. Okay. Okay. Let's do a couple fill in the blanks to warm up. So here we go. So objects in contact transfer heat with and involves density of um, density of layers of different temperature. Okay, so let's go ahead and fill in the blank. I got a couple people here, so let me know other than Lisa, who else is here. And for all three of you, you can kind of fill in the blanks here. Let's see. I've got two. It says objects in contact transfer heat with and the second one involves density of layers of different temperature. So see if you guess which one is number one and which one is number two. If you can guess either one, go ahead and punch it in. And those that haven't, say hello as well so I know who's here. It may be a small group because I had to let you know at the last minute. I know that. We'll give everybody one more minute and then off we'll go. Okay, objects in contact. In contact means touching. Transfer heat with And number two, involves the density of layers of different temperatures. So can we fill in either one? And you two others, please say hello so I know you're here and who you are. And Lisa's got them both. Looking good. Lisa, maybe you're the only one. I see 3 people listed, but you're the only one that's responded. So you may get a personal program this morning. So be it. Okay, yeah, indeed. So if they're touching, it's called conduction. Like when you touch something warm, of course, and when it involves density and layers, and I should have said moving currents, that's convection. Thanks, Lisa. Okay, so last time we went through a couple of scenarios that happen in lakes, and of course, the effect's called turnover. I think we finished this up, but let's find out. I'll ask you, Lisa. Did we talk about the effects on creatures because of turnover? What happens with plants or what happens with fish? I'm guessing the answer is yes, Lisa, but I don't quite remember. I didn't write everything down. Meantime, I'm going to change boards here. Okay, so because no one else is responding, Lisa, I'm just going to talk to you. Okay, so here she's got it. Okay, so we have the effects that fish can't see, and the water is being stirred up through the stirred up through the turnover. Yeah, good. Because of that, of course, the plants. Here, we can just finish it on this one. Hate it when that happens. All right. Also, I can say, all right. Effects of turnover. Um, the plants underwater, the aquatic plants, they don't get as much light, so they don't grow as well during the periods of turnover. Because it's murky water. But on the positive, of course, and I think I told you this last time, when you have turnover, the nutrients from the bottom get stirred up. Oh, we had that. Thank you, Lisa. So we really are all set. Thank you. Then I'll just stop now. We'll go on to something new. Okay. Very good. All right. Okay, let's get my board that fell over and bring that back. Aha, I wondered where that was. No wonder it fell over. Okay, so let's start again here. And again, if there's anybody else out there besides Lisa, say hello so I know who you are. We're going to talk about one last application of convection, but it's a biggie. And actually, although this is the last application we'll do, there's somebody else joined us. Good. Say hello, whoever that is, so I know who you are. Although we're going to do this as the last application, there's one other, and that is air. You might have noticed one of the reasons we have wind is basically the air heats up and then it moves. And then the cooler air is denser, so it goes down and the hotter air rises up. If you've ever seen hawks flying, they'll catch those high currents. They're called thermals, and they're really convection currents that are going up with the hot air. And the hawk just rides them up into the sky. So hawks use convection currents in air. Well, we're going to talk about something really different. We're going to talk about the the Earth here. Okay, so boy, where to begin this? Last application of I can't read that. There we go, Lisa. Last application of convection. I know it's a little shiny there. And that application is going to be, convection currents and Earth's mantle. Okay, so convection current and Earth's mantle. I don't know how much of this you've all had in Earth science, so I'm just going to pretend you haven't had much at all. Here's the Earth. Okay. Oh, good. I got two more here. Okay, my class has tripled in size. So I got UCN. I've got Tully. Thank you both for joining me. And again, I'm sorry to all your classmates that I had to change it at the last minute. Couldn't be helped. I got to teach on Thursday. Okay, so if you guys have just joined us, we're going to do the last application of convection here. It's about convection currents in the Earth's mantle. Okay, so where's the mantle? All right, let's see if you guys know some of this, all right? And Tilly is here as well. Good. Thank you, Tilly. Good. Thanks, all of you. Okay, so let's figure out what the Earth is made of. I'm going to put the layers here. There's a really thin outer layer. And the thin outer layer, it's like an eggshell. That's how thin it is, okay? They go all around the Earth. It's really thinner than I'm drawing, but what can I say? Then I got a pretty thick layer. Then I got this, and then I got this, okay? We're going to put some letters here. So then you guys can tell me what's what maybe, okay? So we're going to take about A, B, C, D, okay? You'll see why I'm doing this, okay? If you know any of the letters, let me know. These are parts of the Earth. You're looking at it from the side, right? Like a baseball that you cut through the middle. Okay, and I want to know what part A is called, B, C, and D. So if you know any of them, let me know. And I'll give you a hint. One of them is called the mantle. See if you can remember where the heck that is. Yes, you may not have had this for a while. I hope you had it at some point. It's really important because we ride around on this thing called the Earth the whole time. I see a couple others have joined us, so say hello if you're just coming on. For everybody, what are A, B, C, and D? Super, yeah, good. Lisa reports that A is the Erdkern, and that's right. We're going to call it in English the core. In fact, we're going to say it's the inner core. So, everybody, can you guess what B is called? Yeah, UCN's got it as well. So that's the core. And if that's the inner core, B is going to be the what? And UCN has it. Thank you, UCN. So it's the outer core. Now, these two are really, really hot. Okay. And I don't know how hot. It's thousands of degrees Celsius, but it's hot. Okay. You wouldn't want to put your hand in there. This one, the inner core, is a solid. The outer core is a liquid. I'll just write that here. You got it. Okay. Some others have it too. Super. Can you guess then what C and D are called? Which one is what, maybe? If you haven't heard of it, you're going to learn something new today. Yeah, Tully's got it. Good. C's the mantle. So it's this fairly big area, and it's kind of like it's like a silly putty. Silly putty. It's like a thick, gooey. I don't know how to describe it. It's not quite a liquid, and it's certainly not a solid. Got the outer one as well. It's called the crust. So the crust is a solid, and the mantle is sort of a. They call it a plasticky liquid, so it moves really slowly. Okay, so what happens is, and thanks everybody for participating. You're a small group, so I appreciate that very much. What do I got? I got, just to make sure, I got Tilly, I got Yusian, I got Tully, I got Lisa. And if there's anybody else there, let me know. Okay, so what happens is, because this is really hot, the mantle is in contact with B here. And so the fluid right here, this part of the fluid gets really hot and it gets less dense. And if it gets less dense, which way is it going to go? Towards a lower pressure up here or a higher pressure? So right where my finger is, if that heats up because it's right next to the core, where's that stuff going to go? That material in the mantle. When things get hot, what happens to their density generally? And I guess that's a hard question because I'm not getting a lot of response yet. So if I got some hot liquid here, the hot liquid's less dense. Where's it going to go? Lisa's got a guess here. She says where there's low pressure, it will go. Yeah, it will go where there's lower pressure. Right. and that's going to be up. So what happens is this stuff, this plasticky liquid in the mantle, think of it as like a really thick liquid. That'll go up. Well, but that means the stuff that's up here, the liquid up here that's denser is going to go down. And by God, we've got a current forming. And while you're giving me the name, these happen all over the place. So here's another one. All over underneath the earth. We can't see it, but it's happening all the time. And it's been happening for billions of years. Crazy, huh? Isn't that neat? So there's giant convection currents. How big are these currents? Well, this from here to here is like several thousand kilometers, okay? So these currents are big. All right, let's just finish this up. Okay, so what's happening here? I'll just write up here. Convection currents in Earth's mantle form as hot less dense mantle rises and denser cool mantle sinks. So this is cool up here. This is hot down here. I know you can't see a lot of that, so I'll try and tilt the board maybe so you can see a little bit more. Okay? While you guys are writing, can I ask, have you had this before in another class? Yes, yes, no, no. Does this look familiar from something in Grundschule or something you've had somewhere else? Okay, UCN, it's your old school you had some of it. That's cool. And from Tilly and Tully, the answer is no. Okay, so this is what drives our Earth. And what I mean is, although you may not realize it, the Earth is moving under your feet. And what's happening is because of these currents, we're going to draw another picture in a moment, what you've caught up. Because of these currents, the last part, the crust up here, breaks up into pieces called plates. You might have heard called plate tectonics. Well, the Earth's plates then are moving because of these convection currents. And I'm going to show you that in another picture in just a moment. So while you're catching up, let me erase my old board. And we'll do something together with this. Okay, so here we go. Okay, I think I'm going to change now. We'll refer back to that if we need to. Let's go ahead and draw this. Okay, here we go. So we're going to draw a close-up of one of these currents, okay? And what happens is, so here's the current, here's the convection current. Okay, I don't want to do this. Well, here's the crust. Okay, underneath here's the convection current. So we said it's going up like this. Okay, so this is the mantle, and up here's the crust. All right, so far? Don't worry, we're going to fill the rest in. Well, it turns out that at some areas, the convection currents can go opposite each other. Here's what I mean. See how this arrow is going up and going left? What if I have another one next to it going up and going right? And then like that. Well, what happens is the pressure from this mantle going this way pushes the crust this way. Isn't that weird? So this crust bit right here is going this way. So this is the surface, okay? You're up here somewhere. Okay? That's you. Okay, but this crust bit over here is going the other way. And where they join, right in the middle, draw that more carefully. Where they join in the middle, I get new lava comes up and cools. There's more or less a boundary right here between them. So these two things are called plates, okay? And so again, this plate's going this way. So I get new lava, and there's, to be honest, there's little underground volcanoes here, right here. New lava comes up, and this is all oftentimes under the ocean. So actually, you're not going to be standing on the crust here, because this is all happening underneath the ocean. So I better put you in a scuba diving suit, but I can't do that quick, okay? All right, you're underwater. Sorry about that. Okay, so here's the ocean. So I got the crust going this way and this way from this spot right here. So this spot has a special name, and I'm going to write it in green. Okay, so the spot, let's see if you can see over here. Yeah, you can. It's called the spreading center. Spreading center. And it's where new crust is formed, because the plates are moving away from each other. Okay, here's a fun thing. They're moving away from each other at like 5 to 7 centimeters a year. So not much, but you add a few thousands and then millions of years, and they've moved a long way. So crust, so we're talking about 5 to 7 centimeters per year this way, and then the other one 5 to 7 centimeters the other way, okay? So it's like the little speed of the crust. So you and I are like riding the eggshell, and the eggshell is moving like this. Okay. Now you might say, well, where the heck is that happening? Well, you ready? Let's see if somebody knows for fun. Maybe at UCN, you're old school, you learned this. Where is this spreading center? There's several on the earth, right? Or underneath the water, underneath the oceans. Where's the closest one to us? Where's the nearest spreading center? Not as far as you might think. Where's the nearest spreading center? And then I'll draw a little picture again on the other board. See if anybody knows. And I'll tell you, it's water, and then there's a continent that begins over here. Okay, so I'm exaggerating it, but anyway, there's a continent here, and then there's a continent here. But it's all part of the crust. Anybody know? The Alps, yine. The Alps were formed a little differently, Lisa, but we're going to see maybe how they formed too. Okay, this is Europe over here. And this is North America. I'll write NAM. So the US and Canada and Mexico over here on this end. So more or less the continents ride on these crust slabs, these tectonic plates. And Europe's on a different plate, okay? And those plates are moving apart. And they're moving apart right at this spot here. And that's called, where can I write it? It's called the Mid-Atlantic Ridge. You might say, ridge? There's no ridge there. Well, there's little mountains, and underneath the ocean, you get these little mountains that form, and they've taken a submarine down there, and by gosh, yeah, totally knew it. Atlantic Ocean, good. So that's this spot right here. That's the Mid-Atlantic Ridge. Okay, we're going to draw it a little more here carefully. How are we doing on time? We're doing okay. I don't know if I told you this, but I studied geology, so this always makes me really, really excited. And the other one of these is called the Pacific. It's out in the Pacific Ocean. There's another spreading center, as it's called. Okay, so spreading center. That's an important phrase. So new crust forms. Okay, so we okay? Okay, we're gonna make a little close up of this thing. All right, so now pretend you're looking from up above. We're gonna do a little map here, like a map. I don't know who you are, Fato King. If you're in my class, great. If you're not, then please leave. And I don't even know what you're writing. But if you're not, I'm gonna mute you in a second. Okay? So Fato King, either identify yourself or take a hike. Okay, so here we go. I've got so there's North America. Okay, there's Florida. We've been there. And then over here we got Europe. So let's do a little bit of Europe, the UK, and let's do Mediterranean. There's Italy. And there's Africa. And here's South America. Okay. Okay. So we're talking yo. All right. Yo, or whoever the heck you are, you're out of here. Bye. Good. All right, whoever that was. Okay, I've gotten rid of them, so they're done, whoever the heck it was. Okay, so here we go. So I want you to know that, well, in the middle of the Atlantic Ocean, we got what country there, folks? You might have flown over this country. What country is that? Well, I'll draw it out here. Again, you might have flown over this country. It's fairly icy. And that country is called, well, I'm tired of waiting, Iceland. Okay, all right, so, all right, there, a couple of you did get it. Okay, here we go. Let's draw this ridge. So underneath the water, now we're looking from a bird's eye view, we say, right? North America, Europe, Africa. So it turns out that ridge is under the water and it goes through Iceland and it goes all the way between North and South America. Now, here's the cool thing. They did not discover this until the 1960s, which may seem like a long time ago to you, but I mean, physics was figured out in the 1500s, chemistry in the early 1900s. Geology was not figured out till the 1960s. And even then, a lot of people didn't believe it. But here's what they found. The rocks, when they took samples, they took a ship and they dug cores all the way across here, okay? It's called the Deep Sea Drilling Project. Ah, Frederica's here. Good. And the Deep Sea Drilling Project found that the rocks closest to the middle of the Atlantic were young. And then as you got away from the middle, they got older. So older. And then they got very old as they got near the coast of North America. And they got very old as they got near the coast of Europe and Africa. So what they guessed is just exactly what we talked about, that the plates, that the Earth is made of plates and these things are moving. So they said, hey, and it was a guy by the name of J. Tuzo Wilson from University of Michigan. He said, hey, I think these plates are moving apart like this. And that makes sense because if you've been on Iceland, what do they have a lot of on Iceland? What do they have a lot of on Iceland if you've been there or seen movies about it? Give me some evidence that new crust and things are happening in Iceland. What's Iceland got? Well, besides ice, got a lot of something else too. Everybody says ice. Yeah, I know, but besides ice. Starts with a V, rhymes with volcano. All right, so they got a lot of volcanoes. And it turns out Iceland was formed because of this new rock coming up. So in a lot of the ocean, it looks just like this, but in Iceland, it's a big, huge country that's formed right on the mid-Atlantic rift. So Iceland is way cool. Yeah, so what they figured out is, hey, these crusts, so the plates are moving again like 5 to 7 centimeters this way and 5 to 7 centimeters this way. The whole theory, I want you to know, it's called plate tectonics. And the theory really is, hey, our world is made of plates that are moving around and hitting each other, or in this case, moving away from each other. So now comes the fun part, okay? These guys figured out, hey, if the rocks here are moving away from each other, somewhere on Earth they must be moving towards each other. Like here, if I'm making new crust, right, then somewhere on Earth there must be crust being destroyed. Now, earlier, Lisa said, like Italy. It's not Italy, but it's another chain of mountains. So now, let's go. I wish I had a third board, but I don't. And I got just enough time, so let's do this real quick. Let's go now to South America. So here's, well, it's not much of a picture, but that's South America. Okay. And here, turns out, yeah, this plate's moving this way. But there's a plate out here where the Pacific Ocean is, and the Pacific plate is moving this way. So my question to you is, what formed right here along, it's still forming today, what is forming along the coast, the west coast of South America? What's forming there? I'll put that in green. In other words, here I've got two plates that are hitting each other instead of spreading apart. So what formed? What do you think will form when these things hit each other? So right along the coast. Pacific plate, that's a South American plate where they're hitting, what will form? I'm running out of time, so quick answer. Quick. Well, I'm going to start to draw some because I'm running out of time. It's a bunch of mountains. Right. Okay, Tully's got it. They're called the Andes. And what happens is I've got a plate covered with ocean, and it hits this other plate with continent on it. Right? There's South America, and there's the plate, and they hit, and one goes under the other. So one plate, as it goes underneath here, it hits this. It's called subduction. And so there's the Pacific plate, Pacific, and it's going this way, and the South American plate's going this way. And as they do, this thing melts down here, okay? So it melts and gets hot, and both the crushing and the hot rock rises up, and I get both volcanoes and mountains here where the two plates hit, okay? So isn't that kind of cool? So where one area I've got new rock forming, another area I've got the rocks that are being subducted. So one plate goes under the other and just gets melted, okay? So what I drew, that little red stuff here, is not a cigarette, it's melting plate. And this has been going on for billions of years. So these plates, and sometimes they change directions, but they've been hitting each other and pulling apart on the Earth, riding around for billions of years. And that is an essential part of Earth's history. So this is a subduction zone. The opposite is the spreading center. And here's something cool. If you look at a better map than the one I drew, then you'll see that South and North America, if I push them up against Africa and Europe, they fit together like puzzle pieces. Because about 300 million years ago, these two were together, okay? And at that point, they started spreading apart. Isn't that cool? They used to be part of a giant continent called Pangea. Pangea. So this is really the history of the Earth we're talking about, and it's all based on heat. It's all based on convection currents in the mantle that are pushing plates in various directions towards each other. Okay? We'll get to radiation next time, but thank you for joining me. And yeah, have a good rest of your week. We'll see about next week because I got some days off that we have next week. Okay, thanks again, and bye bye.